Hi, folks. We are going to look at three different methods that we can use to add fractions with unlike denominators. That means that my pieces are different sizes. So it's kind of like apples and oranges. If I have one huge piece and one minuscule piece, I can't say that those are equal. I can't say that I have two large pieces or two minuscule pieces. So what I have to do is I have to use a strategy to make them equivalent fractions first. And I'm going to show you how to do two visual strategies using tools and one that's using more of an algorithm. So the first way I'm going to show you is using sort of an array method. So I have these rectangles and I'm going to divide the first one into half horizontally. And the second one I'm going to divide into fifths going vertically. It's going to be important that one of your divisions is horizontal and one is vertical. The next thing we're going to do is we're going to overlay those two pieces. So on my third one, this is sort of where I'm merging them together. So I have my fifths, but I also am going to add my halves. And that's why it has to go two different directions because I'm going to be breaking it into smaller pieces. Now, my 1/2 is going across. So that means this whole top section is all part of my half. So what I have to do is I'm going to take one of these counters and I'm going to put one in each of these boxes. And if I look at my fifth, it's going vertically. So here I have two boxes to put my fifths into. But you'll notice that two have ended up in this corner box where my array sort of meets. So all I'm going to do is I'm going to take it, I'm going to move it down into a different box. So in order to solve this problem, 1/2 plus 1/5, I'm going to start by counting how many circles I've used in total, how many counters. So 5 on the top plus another 2, that's 7. And then I have to look at how many boxes I've created, which in this case is 10 boxes. So 1/2 plus 1/5 is 7/10. And if I think about that, I have 10 pieces. Half of 10 is 5, which matches my red dots, and 1/5 of 10 is 2, which matches my yellow dots. So if I add them together, I've added my 1/2 and my 1/5. The next way I'm going to show you is maybe a little more of the traditional algorithm, but it's going to align with this pretty nicely. So 1/2 plus 1/5. I need to look for a common denominator, which means I need to find equivalent fractions that have the same denominator. So I know, if I'm looking just at the bottom of my fraction here, I know that 2 and 5 can both go into 10. Those are both multiples of 10. So I'm going to start with my first fraction, 1/2. When I'm finding an equivalent fraction, what I do to the bottom, I have to also do to the top. So I know that if I multiply 2 times 5, that's going to give me 10 on the bottom. I also have to multiply my numerator by 5. So I'm going to end up with 5/10. On the other part of my fraction, I'm trying to get to 10 for my denominator. I know that 5 times 2 will give me 10, so I also have to multiply my top by 2. So in this case, I'll end up with 2/10. And now when I'm adding a fraction, all of my pieces are the same size. They're all tenths. So now I can just count. 5/110 plus 2 more, 6/110, 7/110. So my answer is 7/10, which you'll notice is the same response that I got using my array method up here. The third way I can do it is using tools such as fraction stacks, or in this case, I'm going to use the fraction tiles. So you can see here on the side that I've combined 1/2 and 1/5. And what I'm doing is I'm sort of comparing or measuring against the other fraction pieces. So I'm going to take this piece and I'm going to move it. So I'm going to look here. Is it equal to 1 whole? No. Is it equal to 1/2? No. What about thirds? And I'm looking for it to line up perfectly with one of those white lines. So not with fourths, not with fifths. Sixths, that's pretty close, but it's just a little bit larger. Eighths, nope. But look what happens when I get to tenths. When I get to tenths, it lines up perfectly with that break. And what I'm going to do here is I'm going to remove these extra tenths and see what's left underneath. So if I count here, I can see that I have 1, 2, 3, 4, 5, 6, 7 pieces that are each 1/10. So 1/2 plus 1/5 is equal to 7/10. So those are 3 different methods that we can use to add numbers that are fractions that have different denominators, unlike denominators. We can use the same thing to do subtraction, and I'll post another video on that another time.